Okay, this video is for my Calculus 1 class. This is our integration practice lab number 2. So I'm going to kind of go through each of the problems with you, and I graphed everything I could to show you this. So it says use this table to estimate the integral from 0 to 20 of f of x dx. Show all work. So if I ask you to estimate, I want you to do the left-hand sum and the right-hand sum and average them, okay? So the first thing I'm going to do is, so here's my f of x dx, so here's my f of x. I'm going to do my carets here, and I'm seeing that I'm increasing by 5 each time. So that's my delta x. So my change in my x is 5. So if I'm doing rectangles, and I just want you to think how this works. When I do my left-hand sum, okay, I'm going to take the width of the rectangles, which is my delta x, and then I'm going to start on the left-hand side, and that would be how high it is. I'm going to stop one short because I've got 1, 2, 3, 4 rectangles, so I'll have 4 values. So it's going to be 5 times 225 plus 175 plus 150 plus 135. So if you look at it, it'd be like 5 times this, 5 times that. That's how the left-hand sum would be, and I would put it in my calculator. I get 3425. Now my right-hand sum, it still has the width of my rectangles are 5, but now I start 1 over and end over here because you're starting on the right side of the interval. So now I have 175 plus 150 plus 135 plus 130. When I put that in my calculator, I get 2,950. Now, to find the average, so this is my right-hand sum. Okay, so this is n. I'm going up here from 0 to 20. Do you see how my values are decreasing? So this is a decreasing function. Okay, so on a decreasing function, I just want you to look at this as my values go down. Do you see how my left-hand sum is an overestimate? My right-hand sum is an underestimate, so I'm going to average the two and just add them up. So I have 3425 plus 2950 divided by 2, and when I do, my estimate comes out to be 3187.5, which is going to be either the distance traveled or the area under the curve, whichever you want to look at it, but that is the estimate of the integral. So if I ever ask you to estimate that, you can't put it in your calculator. That's how I want you to do that. All right, so let's look at number 2. It says estimate the area under the curve of y equals 2 sine x from 0 to pi over 2. So I just want you guys to remember, when you graph 2 sine x, so it has an amplitude of 2, all right, so let me just kind of set this up. So I'm going to have 1, 2. Okay, sine starts at midline, and cosine starts high. So here is what my graph would look like. It's going to come down to -2, back up to 0. So there's just a sketch. I'm going to show this on the calculator in a minute. Now, when I go through doing this, this is my 0. This one right here is pi over 2. Right here is pi, 3 pi over 2, and 2 pi. So I'm just kind of setting up my graph. Now, when I did graph this, this is what it looks like. And you'll see that they want me to estimate the area under the curve from 0 to pi over 2. So what you're really doing here to here, whoops, I didn't mean to touch that, is you're looking for the area under the curve from here up. So it's just this piece over here, okay? So I'm going to come over here, and basically I'm going to drop this down here, and I'm looking for, whoops, that's a little crooked. So I'm looking for the area under the curve right here. All right, so how do I set that up? It's all above the x-axis, so I can say the area, okay, is going to be the integral from 0 to pi over 2 of my function 2 sine x dx. Okay, when I stick that in my calculator, which we've been practicing in class, you will get the area to be 2. All right, so let's kind of practice that here. So I'm going to bring the calculator up. So I'm going to add a page here, and I'm going to add a calculator. So I want to do that. So the area is going to be the menu. You're going to hit calculus. You're going to hit integral, and I'm going from 0 up here to pi over 2. So pi is right here, divided by 2. Whoops. Yep, divided by, escape. Sometimes it does that. divided by 2 right here. And then here I'm going to put sine x. They always go crazy at first. Escape. X and dx. And make sure you're in radians, and I hit enter. And I get 1. And because I forgot the 2. So let's put the 2 here. My fault. Hit enter. So let's copy this. Hit enter. Let's put the 2 here. My fault. There we go. There we go. So I just wanted to make sure that you can plug it in and see. That would be, I just want to make sure you set it all up. All right, so that's number 2. Let's try 3. Okay, it says estimate the area between the curve y equals x cubed and y equals x to the 4th from 0 to 1. So I'm going to set up just from 0 to 1. That's all they want us to do, 0 to 1. And I've got to graph these both. And the one thing I don't understand is which curve is on top. Because if you're trying to find the area between the two curves, you need to know the one on top and the one on the bottom because you subtract the two. So I'm going to come here, go to my next screen here, and I graphed from 0 to 1, x cubed and x to the 4th. So x to the cubed is higher or above the x to the 4th, and I'm looking for the area between these two curves. So, and the whole thing is above the x-axis, so that's good to know. So I'm going to come back here and say, all right, I'm going to sketch this so it comes all the way up to 1 here. So this one goes here and the other one goes here, and I'm looking for the area between these two. Okay, so this is a 1 here, that's a 1 there, so I sketched it. So x cubed is on the top and x to the 4th is on the bottom. So how you set this up is you want to find the area in the curve between the two curves is going to be the integral from 0 to 1 because that's what they wanted to go. And all you do is you take the one on the top and subtract the one on the bottom, dx. And when you put that in your calculator, you are going to get 0.05. So that's the area between the two curves. So that's number 3. All right, let's go do number 4. So it says sketch the graph of x times x plus 2 times x minus 1. Well, I kind of know what this looks like, but I also graphed it. So we're going to go to the next one. So I graphed it from -2 to 1. That's what they asked us to. And I can tell that it crosses at 0, at -2 is a root, and at 1 just because it's a polynomial. And they basically want you to find the area between the x-axis and the curve. Well, up here, this is cool because it's positive because it's above. Here it's negative. So when we go to do this, we actually have to subtract this because if we just put this in our calculator from -2 to 1, it would say, oh, this is positive. It would subtract that. And if I'm really looking for the area, that's what I have to do. So I'm going to finish this video a little bit later.